Hi everyone, my name is Lishalini Murugan, matrix number DE2100059. So today we are here to present our group project for transform circuit. We are from group 6 section 3. So these are my teammates Farah and also Fakrul. For this project, we are assigned to do the solutions for question 2. So this is the question that we are assigned for.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Nurul Farah Ain binti Nurhan. My matrix number is DE210088. So I will proceed with the manual calculation. So Q2A, we need to find the voltage output of the circuit. Okay, so the first thing we need to do is we need to transform the time domain circuit into frequency domain circuit. So this is the frequency domain circuit. Okay, so we need to change the capacitor into frequency domain. So how do we do it? So the formula in Laplace transform is 1 over Cs. So we insert the value of capacitor here and we will get 50 over S. Okay, so the R will remain the same, 40. Okay, then we use voltage divider rule. Since the capacitor is in parallel with the resistor, we assume that the voltage across the capacitor is the same as the voltage across resistor. Okay, so by using voltage divider rule, we will get 250 over S plus 1 in bracket S plus 5 over 4. So from here, initially, we will have voltage and then we need to multiply with current source. So from here, the current source is 5 exponent negative t. So by referring to the Laplace transform, we will get 5 over S plus 1. Okay, so now we will get the V output equals to 250 over S plus 1, S plus 5 over 4. However, this is not the final answer. We will use a partial fraction and identify the value of A and B. Okay, so after we do the cross multiplication, we will get the value of A, which is 1000, and B equals to negative 1000. So from here, we need to convert back the frequency domain voltage into time domain. So after we did that, we will obtain the voltage output in time domain equals to 1000 in bracket exponent negative t minus exponent negative 5 over 4t UTV. Okay, so that's for Q2A. For Q2B, if IST equal to 50 exponent negative TUT ampere, determine the voltage output of the circuit. So it used the same circuit we did earlier. However, the changes is the current source. So the current source has changed into 50 over S plus 1. So after we did the usual voltage divider rule, partial fraction, then from here we will obtain the value of A and B is different. So for A, when S equal to negative 1, it is 10,000. So when S equal to negative 5 over 4, B equals to negative 10,000. So the final answer for voltage across a capacitor in time domain is 10,000 in bracket exponent negative t minus exponent negative 5 over 4t ut voltage. That's all from me.
Assalamualaikum and hi, my name is Muhammad Fakrul Akidin bin Muhammad Nasir. My matric number is CE210147. So for this project, I'm taking part to do a simulation. So this is the circuit that we are created by using the SimScape. So for examiner's information, we are using SimScape in this simulation as easier for us to execute all the result. Okay, so the first one for the questions 5 to the power exponent of 1 over 2t, we have to insert the value of DC current in the source. Then we apply and then run the simulation. Okay, so the LCD displays the value of V out of the capacitor. And then if we want to look for the graph, we can click on the scroll. And then this is the graph for the first questions. Next, for the 50 to the power of E over 2. Just replace the value here and run the simulation again, and we can read the result at the display. So it's shows the value of 10,000. So the graph can be clicked on the scope, and this is the graph. So that's all for the simulation part. I will continue explain details in the slides that have been prepared. So for the part simulations, I will continue explain. So assume that the system is in direct current circuit. So there is two conditions given for the current, which is 5 exponent to the power of 1 over 2 and 50 exponent 1 to the power of 1 and over 2 to find the output voltage across the capacitor. So in addition, attached here with the graph of output voltage for both conditions. So in the simulations just now, I shows the result and also the circuit that we have created in the simulink. And then this is for the second value. Okay, so as the above result, there are a few summarization could be made. So the first, the author have proved both of the manual calculation and software simulation are the same, and then the theory of mesh analysis has been applied during the manual calculations with the combination of mathematical modeling knowledge. Second, the author have faced some difficulty thing when run the simulations, as this is the first time doing circuit analysis using this platform. But then after a few try plus referring to the multiple sources such as YouTube and also a few websites, so the author finally successful applied all the skills to the simulations and successfully made the simulations. I think that's all from me. Thank you.
For C, we have to compare the results in A and B, which are the manual calculations, and explain what happened when the supply current increases, explain and write the conclusions from result C. So, explained by our presenter previously, the value of V naught T in B is greater than the value of V naught T in A. And from the question, we know that the supply current for the question B is greater than the supply current in question A. Thus, we could conclude that the value of V naught T, which is the output voltage at capacitor 20 millifarad, increased when the supply current increased. So, this is the observation that we could say from our question and also our manual calculation. But this phrase can be proved by the application of Ohm's law, which is V equals to IR. From this equation, we could say that for the constant value of R, the value of voltage increases when the value of current increases. This is because the output voltage is directly proportional to the supply current. This is why the value of V naught T that we get in B, which has the higher current compared to A, is greater than the value of V naught T in A. So that's all from me. Thank you.